In this section, we'll look at data classification when working with numerical data. First of all, classification is key to the interpretation of maps and other graphic representations of data. Classification schemes have a simple goal: to maximize the difference between classes while minimizing the differences within classes. This is actually a fairly tough balance to achieve, as we'll kind of see in some examples, and a poor choice of classification scheme can cause a very misleading map. First of all, the use of numerical scales involves the process of breaking data into groups. We call these groups classes or bins. They're defined by breakpoints. Breakpoints are essentially, if you were to to scale this out, with 0 being to the left and the positive units being on the right, the breakpoints would be on the right side of intervals. We want to keep the number of intervals small because people can interpret maps with too many different classes and class breaks. And a mathematical progression is important instead of arbitrary values. So here's an example of classification of data into groups or classes. On the bottom example, it's very hard to interpret the data. It has to do with percentage of a state population who prefer the term pop to soda or Coke by state. And then on the top, the percentage of the population who preferred the term pop by state, shown in a way that breaks it down into classes. We can start to really understand the number of states that fall into various classes by breaking it down this way. So the choice of data classification scheme depends on the data in the map. Two frequently used classification schemes are quantiles and equal interval. You'll work with this in ArcMap, where under symbolization you can choose the classification scheme. Quantile classifications divide data into classes, each with an equal number of units. For example, the top 20%, the second 20%, the third 20%, fourth 20%, and the bottom 20%. It avoids clumping most data into the main category, and maps appear to show more variation in data, but there may be a high variation in data within a range. By contrast, equal interval classifications use equivalent data ranges to determine the range of definition. The number of units, that is, like for example states in a population map, in each class will vary, and the data varies less in each range. Maps may appear to show less variation. In quantile mapping, we place the same number of data values in each class, and you'll never have empty classes or classes with too few or too many values. Quantile classification is used frequently because it provides information about the shape of the distribution. However, you have to be careful because sometimes you'll have a huge variation of data within those classes. Here's an example of a map that's been broken down, where data has been broken down into quantiles. We see here 5 classes with roughly equal number of census tracts in each class. What you can see, though, is that the values vary a great deal. So the lowest category ranges from 0 to 70, the second category from 71 to 114. That's not very much of a range. And then the top category from 212 all the way to 599. So the variation of ranges in these quantile classification schemes can be a problem for interpretation, but they can be useful ways of looking at how the data are distributed over space. Equal intervals may be the easiest to understand for the map reader because the ranges tend to use familiar interval widths. For example, you would break it down by 1 to 10, or 10 to 20, or 30 to 40, and so on, 100 to 200, and so on. It's not very good for highly peaked or skewed data distributions. In other words, where you have a condition where, so you might have a state like, Illinois would come to mind as a good example, where most of the counties have a fairly low population, and then all of a sudden you get to one county, Cook County, which has over 3 million. And so this would tend to skew the data a great deal. Here's an example of an equal interval. In this case, many of the tracts fall into the lowest classes, and you definitely see less of a range in terms of the data. So, for example, there's only one census tract in this case in the middle of Pittsburgh that shows up in the highest classification category. So here's a comparison if we were to break this out. This comes from your textbook, where you have the percent population change using quantile classification compared to percent population change using equal interval. Quantile classification on the left shows us that there's quite a large deal of range and variation within those categories, but it does break the state down in terms of different counties, broken down into roughly equal quantiles. Equal interval shows that you have more counties in certain categories. Most of the counties show a little bit of population change, but not a lot, and they break down into the same class. So it kind of depends on the purpose of the map and how the user will be using the map. Another way that you might break data down is through using natural breaks or jinx classification. This may be useful for exploratory work, for example, to find out more about the data and the breakpoints, and the breaks are clustered to maximize the differences between classes and to minimize the differences within classes. So in other words, you could avoid the problem of having a huge variation of data within a single class. There are relatively large jumps in values between classes, and class intervals are variable in width. Class ranges are specified to the individual data set, and it is difficult sometimes to compare maps across multiple units. Like, for example, to have a population change map of Texas comparable with one of California. In this case, the jinx classification would be derived for each individual map on its own. You're going to have wide variations in classes between two maps. So here's an example of a couple of maps that use the natural breaks method of classification. In this case, percent renter occupied versus percent owner occupied. This is a good way to cluster data where you start to see greater differences among the distributions between classes. Notice the class boundaries on these two maps vary, so it's hard to make comparisons between the two maps. It's important to be aware of the difference between enumeration and sample data. Enumeration results from a direct head count, whereas where 100% of households are actually asked and counted. Sampling, though, is estimated from a smaller population sample. Enumeration areas include census blocks, block groups, tracts, places, counties, and states, and those are from smallest to largest in order. Census blocks fit into block groups fit into tracts fit into places fit into counties, and counties fit into states. And that concludes this section on data classification. Next, we'll talk about GIS queries.